Okay, well, so we are live now. Okay, so let me start the uh, concept first. Meanwhile, so in week 9, okay, so you have seen the method of parameter estimation, right? Actually, now we are
Yes,
focusing the concept of parameter estimation. Because in real life scenario, this is something we don't know, right? We don't have information about parameter. Okay, now. So how will do? How so? What are the procedures? I mean, is there any principled way or is there any mechanism to estimate our parameter? So there are two approach which you have studied in week 9. That is called method of moment estimation, right? And second
and
one is
maximum
maximum
likelihood.
likelihood estimation, right? So these two you have discussed. We have seen. Yesterday we covered first video. What you're trying to say, Aditi?
Yesterday we did a 10.1 video from the lectures. Yesterday also we had a session, no? So
Okay,
in
so you are
that,
talking about that TA session.
yes,
Okay, no
in
problem.
that we covered first part of the 10th week.
Fine, fine, no problem. So I will. I'm just starting from very first topic of the week 10. Okay, I will cover
Okay,
every topic.
okay. Thank you.
So, sorry. So in these two methods, one concept was there. Like suppose I have parameter, unknown parameter. This is theta, and this is unknown to me. For example, and this is something we are trying to estimate with method of moments and maximum likelihood estimation, right? But there was one concept, they treated this theta as a constant, right? Yes or no? This was that was the main idea behind this. Okay. Now suppose let's change the scenario. Scenario means suppose I'm saying, okay, let me start with the very basic thing. I'm just assuming Bernoulli P distribution. Okay. Suppose I have a distribution. I have observations. Let's say I'm saying x1, x2, so on, x2, xn. These are from Bernoulli P, for example, suppose. And what this means? Suppose I'm saying this is Bernoulli P, so this P is nothing but this is the probability of success, right? Means I will take value 1. Yes or no?
Yes, 1 and 0.
Correct. 1 and 0. Now, thing is, suppose you are an analyst or you are a statistic, sorry, you are an analyst and you are suppose data scientist and or something. So suppose from your past experience and all, right? Maybe you have some prior belief, right? Or you may have some idea, right? Basic idea, or from your past experience, you know this. Suppose, okay, that is something. Suppose from your prior experience, you can simply say, you believe that. I mean, I believe that this bias P. I'm not assuming this P is unbiased. If this is unbiased, then P will be half. We don't know this P. What we are saying, I believe that this bias P is, let's say I'm saying, somewhere close to 1. That's something you can treat, right? Yes or no? Or you can simply say you have an idea or you have a thought about your parameter P, correct? Rather than treating your parameter P as a constant, you are saying you will be having or you have some idea, some prior belief about your parameter. So far, so good. This is something. Suppose you are saying you may have some belief about your parameter, correct? Yes or no? Can you say something about from your prior experience? I can say yeah or not. Correct? Are you getting what I'm trying to say here? Yes, no.
Yes, sir.
Okay, fine. Yeah, so you can simply tell me if you are not getting the things. Okay, so thing is that in method of moments on maximum likelihood, we are treating our constant, I mean our parameter as a constant which is unknown, and we are estimating through those methods. Now, so, is it necessary my parameters will always be constant? No. For example, you may have from your prior experience, you can simply say your parameter p has some, I mean, it is very close to 1 or it is very close to 0.5 or something like that, you can simply say, means you can simply say you have some belief system about your parameter. So main question is, so you can simply say, is there any method or is there any principled way in which I can or you can, whatever, I'm just writing I can incorporate our belief. So this belief, so thing is that you have some belief about your parameter. You are simply saying, is there any method, is there any principled way in which I can incorporate our belief along with the data, right? You will be having some data, right? You will be giving some observations along with data into our estimation process. Okay, so this is the main question. I mean, you see, if you are saying you have some belief about your parameter which is unknown to you, you are simply saying based on your prior experience, like you are simply saying this p is close to point, so is this p is close to 1 or this p is close to, let's say, 0 or something like that. So is there any method in which I can incorporate our belief, or I can simply stop? We can't stop, right? Basically what we are doing, so from here we are simply saying, so okay, so this p, suppose you have some prior experience, you can simply say, first of all, this will lie between 0 and 1, right? You will say this p is close to 1, so you will say this p is, suppose for example here, 0.9, correct? This p might be here, or else it can be something like that also, right? It can be anything, right? So key idea is, it will depend on your prior experience, whatever you are saying. So what we are doing here, if you see, basically what we are doing, we are just putting weights to the values of p, or simply I will say, I'm going to treat this belief as a random variable which has some distribution associated with it, correct? Yes or no? See, this can be zero point
Yes,
0.9,
sir.
this can be zero point 0.5, this can be 0.8, something like that, right? So what we are doing, see, it is not a fixed value, right? So what we are doing here, we are treating this belief as random variable, okay, which has some distribution associated with it. So basically, okay, can you tell me what do you mean? What do you understand by this? Some distribution associated with it.
The belief might be following some or the other, either Bernoulli, the given distribution like Bernoulli or any other. That's what I understood.
Okay. Any other thought? Basically, yeah, what we are doing here, we are just simply, whatever your belief is there, you are just codified, right, using a probability distribution over theta, right? Correct? So this is some distribution, and there will be some probability distribution over theta, means, or simply you can say, okay, as distribution associated with it means, it will tell you what is the chance that your true parameters will fall in a particular interval. Okay, something like that. Okay, so far so good. This belief and some, this we are treating as a random variable. So far so good. You are getting idea.
Yes, sir.
Okay, now, so what we are saying here, belief we are codified using a probability distribution. For example, suppose this is a p theta. For example, theta I'm treating as an unknown. So what this p theta is nothing but, it will denote you the prior information, or I will say prior distribution. Okay. Now, so what I will do from now onwards. So what we are interested to see from here, we are, see, this is our goal. This is our main goal or main objective. Is there any like method, or is there any principled way in which I can incorporate our belief system along with the data into our estimation process? What we are doing, this is prior information you will have. So you are going to use this prior information, correct? You will use the data here, and based on this, I'm going to update my belief. So far, so good. What? So, are you able to understand the algorithm? Like,
Yes,
you
sir.
have some prior information, you will use your data, and you will update your belief, right?
Yes,
Means,
sir.
what this it will denote? It will basically denote, given the data, what is the value of p theta? Okay, so this is something we have to calculate, and this is nothing but I can find with the help of Bayesian estimation. Okay, fine.
Yes, sir.
Correct. So what we are doing, nothing but, so let's I mean, we can summarize in way like p theta. P theta is nothing but, what is this? This is the prior information, right? Correct. This is the prior information about your parameter. It can be anything, right? Now you are going to use the data, correct? Based on this data, I will update my belief. Okay, means what will be the value of your unknown parameter after giving, I mean, once you will apply your the observation. Okay, so this is something called the posterior distribution. You maybe you have heard about these things, right? Correct or not?
Yes,
Right.
sir.
So what posterior distribution does? So okay, can you tell me from where can you interpret something by this chart or this information?
Prior information into data.
No, no, you are. So I'm asking in terms of theoretical way. I mean, what you can interpret from here? What this posterior distribution will represent?
What I understood is that basically we will have some preconceived notion or some prejudice about about the distribution of the data. Then
Hmm?
after going through the data, we'll get the final distribution, like what is the actual distribution and what we thought of, and
Correct. So
and
basically, okay, can I say, okay, correct me if I'm wrong. Okay, can I say this posterior distribution represents the updated,
updated belief
correct, yeah, updated belief or updated knowledge. Okay, about what? About, tell me,
estimator.
about the parameters. Yeah,
Sorry,
correct. After observing the data, yes or no? Can I say? Now, first of all, tell me. Now, this algorithm is clear. I mean, this agenda is clear in Bayesian estimation.
yes, sir.
Correct. So you will be having some prior information based on your prior experience and all. Data will be given to you. Based on the given data, you are going to just update your knowledge or update your belief system. Correct. Okay. Now, so how will you proceed for this? So there is, since we are calling this as a Bayesian estimation or Bayesian modeling, so maybe you have heard about Bayes theorem, right?
Yes, sir.
Okay. Since Bayes theorem is help, so we are, I mean, we got this through the help of Bayes theorem. That's why we are calling as a Bayesian estimation. So in Bayes theorem, what is the formula? Probability of A given B is nothing but probability of A intersection B divided by probability of B, right? And this thing in the numerator part, I can simply write probability of B given A into probability of A divided by probability of B. Yes or no?
Yes, sir.
Correct. Now, by using this, can I say, suppose I'm saying I'm going to treat A as a parameters. Okay. We'll derive the formula from here. So this is something nothing but theta. What is the B here? B, I will simply say my data. Data can be, let's say I'm saying x1, x2 up to xn. I think we can simply denote as a capital S. So far so good. Yes or
Yes,
no?
yes, sir.
Now what we'll do, probability of, so what this is theta unknown to us, right? What we are doing? the given data theta, right? So I will say probability of theta, and you can say A is theta, given that my data, right? So data I'm just writing S, right? Hope it is fine to everyone. Now what it will be, okay, so okay, let me write, instead of S, let me write x1 x2 xn. That will give you more idea. Suppose this is x1 x2, these are your observations given to me. Okay, now probability that what it will be now, tell me, x1 x2 up to xn
Given theta,
given theta into p of theta divided by p of.
probability of x1, x2, xn.
Correct. So I hope you know this is called a likelihood, right?
Yes.
Okay, what is the likelihood? What do you mean by
Same.
the likelihood? Yeah, this will be s given theta, this p theta divided by p of s. So this p of s is independent of theta, right? Correct. This doesn't involve the theta, so that's why we can simply write probability of theta given as, we can use the proportion. I mean, we can simply write, and instead of equality sign, we can say probability of theta given as is proportional to probability of s given theta into p of theta. Yes or no? That,
Posterior into likelihood.
so what we are doing here, P of theta given S means data is proportional to probability of
Posterior
data given theta into P of theta. So what is
theta.
this? This is the posterior.
Posterior
Posterior is proportional to, this is the likely,
likelihood.
and this is the
Prior.
prior. So this is the main idea which we are going to use in the Bayesian estimation. Means posterior distribution is nothing but proportional to the likelihood times prior. Okay. So what likelihood represents, anyone? I mean, I want the general idea about it. I mean, I want to listen from your side. What is the likelihood? Tells us.
Maximizing.
No, you are maximizing the likelihood function. That is the maximum likelihood estimation. I'm asking what is the likelihood? I mean,
Possibility.
possibility of what?
Data based on a condition.
That
Uh,
is a function of parameters.
So the
somewhat,
possibility of
somewhat.
the data to alter the parameter theta.
It is a function of parameters.
Function of parameters. No. Okay. I'm going to write. Tell me whether. So basically, likelihood just tells us what is the. It will give you the idea about what is the probability of observing my samples, right? For a given theta. Is is this right or not? Correct. So this likelihood, so from here you can simply interpret. I mean, it tells us that what is the chance of observing your data, right? uh, of, I mean, observing your data or observing your samples for a given theta. Yes or no? So if you see in likelihood, what we are doing, we are just simply multiplying the values, right? Suppose x1 into theta, x2 theta, we are just multiplying the PDF or PMF size. Yes or no? So what we are doing, we are interested to know what is the probability of observing your samples for a given theta. Correct? Okay. So till now this idea is okay.
Yes.
Fine. Did you get the idea? I mean, what is the use of the? I mean, what is the main agenda of this Bayesian estimation? Yes, no. Is that all right? Correct.
Yes, sir.
Yes.
Okay. One more thing. Can you tell me where this Bayesian estimation is useful? Bayesian estimation, or sometimes it will call, if you or Bayesian modeling. Where it is useful? Anyone? Any idea?
I think in astronomy there is Okay.
Then we know the prior information about the thing we are dealing with.
Sorry.
When we have information, right, like our domain knowledge in some particular area is very good, so we
Hmm.
can take a prior estimate. That so Bayesian estimation can be
Actually,
useful there.
yeah, Bayesian estimation, this Bayesian model is, I mean, it's useful, means, I mean, lots of places. I mean, the very first is machine learning, right? ML. Because in ML, when you learn, right, unsupervised learning and all, right? So under unsupervised learning, you have to learn clustering and all. Then you will go, what is the estimation? Under estimation, you will learn. I mean, we are doing with the Bayesian modeling and all. If you go in any field, right, healthcare and medicine, finance and economics, and like statistics and data analyst, social sciences, I mean, where this prior information is, I mean, you can get some prior information and all, right? So I mean, social sciences, I mean, I mean, it is very applicable in psychology, sociology, political science, and all. But that's not useful or for us. But just I'm giving to some rough idea to all of you. So basically, whenever you will move, right, in diploma level and all, so this Bayesian estimation you will see in machine learning. Whenever you study this unsupervised learning, supervised learning, and all. So basically, you will, I mean, you will use this Bayesian modeling under the estimation process in supervised learning. Sorry, unsupervised learning. Okay. Now that's not
So
will.
will we,
Uh,
uh, will we use likelihood and methods of movement also?
yeah, like under estimation, you will do likelihood because in Bayesian estimation, likelihood is inbuilt there. Method of moments is also useful, but not that much level. Okay? Because in see, method of moments, what we are doing, we are treating our theta as a constant, right? That is something called a frequentist approach. Okay, and you may have seen in method of moments what we are doing. We are simply denoting m1 as expected of x1, right? And m2 as expected of x2, right? Yes or no? This is something we have done, right?
Yes.
Yes, sir.
But, okay, anyone can tell me why we are equating this thing? Any idea why we are equating?
So because the name suggests methods of movements, that's why.
Okay, is there any algorithm behind it? Why we are equating? Is there any reason? Anyone just think a little. Yes, no. If you are not getting idea, you can simply tell me.
No, sir.
No, sir.
What about others? No.
No.
No. Okay. No problem. Okay.
We all
So
we only know to equate
in
and get the
okay,
answer.
that's okay. That's fine. No problem. You have seen this weak law of large number, right? Under weak law of large number, you may have seen what we are doing. This x bar is converts to mu in probability, right? See, when n is large, we are saying this x bar sample mean will converge to distribution mean in probability, right?
Yes, sir.
Correct. What is this sample mean? This is the sample moment, right? This mu is nothing but now we are denoting expectation of x, right? Is the population moment or distribution moment, something like that. So actually, see, this method of moments is useful. So here we are saying, right, x bar is will converge to mu in probability, right? So that's why we are equating this sample moment to population moment or distribution moment. Actually, in probability we are talking, and this if you see this name suggests a weak law of large number. I mean, it gives you very weak. I mean, it see, even though it's saying x bar is close to mu, but in probability it's not saying it is not giving any information like in distribution here. I mean, x bar, see, maybe you have seen, if you can simply search strong law of large number and all. Under a strong law of large number, what we are saying, x bar n, this is converged to mu almost sure or in distribution. So that is the difference. So here gives us very weak thing. Okay, that's why we are moving to the maximum likelihood and we are moving to the Bayesian estimation. Okay. So let's do the some activity question. Okay, I hope this rough idea is okay, right? So do you any doubt from activity? Okay, just a minute. Okay, what about question number 1? Is it fine to all of you, or should we discuss this question?
Please
Sir,
discuss.
discussion.
Should we discuss? Okay, let's discuss this, and then we'll move to. I will give you some. I see this is for discrete, right? Then we'll move to the some. I will give you some rough idea about in general as well. Okay. Okay. Let me discuss this question, and then we'll move. Okay. Now, so here it is asking for posterior mode and posterior mean. Okay. Let's see. No problem. So you have some 5 IID samples 11010 from a Bernoulli P. It's a activity 10.1 question 1. Okay. So you have some 5 IID samples 11010, right? Am I right? Yes, from Bernoulli P. These all are from Bernoulli P. We don't know P, correct? And this, it is saying, see, this P has a prior distribution which is uniform 0.3, 0.7, correct? So this is the prior distribution. Yes or no?
Yes, sir.
Correct? So what is the probability that P will take this 0.3?
0.5.
0.5, right? Or half. And same for this also, right? So, okay, now this is the prior, correct? And this is the data given to you. So what we are doing, we based on this data, I'm going to update my prior belief, right? Yes or no? So what is this S? S means what are the observations? You have simply x1 is 1, x2 is 1, x3 is 0, x4 is 1, x5 is 0. Yes or no?
Yes, sir.
Yes, sir.
Correct. Now, so what is the thing? So what we are doing, probability of theta given data, right? It's equal to probability of data given theta into p of theta divided by probability of data. This is something we have to do, correct?
Yes, sir.
Yeah, here in the place of theta, I have p, and what is the data? I'm just writing s, right? Okay. So what we have to do now? Okay, so here you can see p has two value 0.3 and 0.7. Since we are going to use the this Bayesian estimation, it is asking about posterior mod. So we'll see for which value of p we are getting the greater value or higher value. So we'll see. Okay, let me write down first like this. Sorry, into probability of p divided by probability of s. Now,
Yes.
so we'll see for p is equal to 0.3. What is the probability that p will take 0.3 given that for the given sample? Okay. Then into probability that p is equal to 0.3 and divide by what about p of s in the denominator. So I can simply write for both value, right? Because this means probability s given p is equal to 0.3 into probability that p is equal to 0.3 plus probability that s given p is equal to 0.7 into probability of p is equal to 0.7. Is this denominator part is clear? This is law of total probability. Okay,
Yes, sir.
fine.
Yes.
Yeah, let's do. So whatever the samples we have, we have 1, 1, 0, 1 and 0, right? This is the samples. Now can you tell me what will the value of for this?
3/5.
No, see,
3/5.
this is the 0.3. What this means? What does this mean? I'm saying these samples are from Bernoulli P, right? That means I have success probability 0.3. And how many times 1 is occurring?
3.
So it will be 0.3
3
cube,
to power 3.
right? And 0.7 square, right? Now what about this? P will take 0.3.
Sir, I did not get this part. Point
See,
three to the
what is
power cube.
you have samples this, right? 11010, correct?
Yes.
And what is this P denote? P denote and this samples from Bernoulli P, right? And this P is what? Success probability, right?
Yes.
Yes.
Success probability means we are talking about how many times one is occurring, correct?
Yes.
So if you see how many times one is occurring, 3 times.
Yes, sir.
What is the value of P we are taking? First, 0.3. It will be 0.3 cube into
Yes.
0, 0. That means 0.7 square,
Yes, sir.
1 minus P. And what about this quantity?
0.5, sir.
Right?
0.5.
It's a 0.5. The denominator part
So
is okay, right?
how it is 0.5, sir?
What is this prior? Prior is given to you uniform 0.3, 0.7, right?
Yes.
So what is the probability that P will take 0.3? Half. What is the probability P will take value 0.7? Half. Fine?
Yes, sir.
Okay. Okay, denominator part is okay to all of you. How I have written this case? Okay. So this is the law of total probability. You can simply see. So if you see for this part, right? This is the same, right? 0.3 cube, 0.7 square, 0.5.
Denominator part once again.
Sorry.
Sir, I'm saying that can you explain denominator part once again, the law of total probability?
Okay. So that's okay. Are you okay with the Bayes theorem?
Yes, sir.
Okay. In Bayes theorem, what we are doing? Suppose I have two events, right? Let's say this is the E1, this is the E2, and there is another event A, correct? So if I will say what is the probability that A has occurred in E1, so what you will write probability that A given E1 into probability of E1, yes or no?
Yes, sir.
Divide by probability of A. And what is the probability of A? How will you write probability of A? Means probability of A and E1 or probability of A and E2, yes or no?
Yes, sir.
Correct. So this A intersection even how you can write? I can simply write probability of A given E1 into probability of E1 plus
Yes, sir.
probability of A given E2 into probability of E2.
Okay, sir. Okay.
Clear? So now here instead of E1 E2 our P is taking 0.3 0.7. Fine.
Yes, sir. Got
Clear?
it.
Now okay, tell me what about this quantity P of S given P is equal to 0.7. What does this mean? And given that P is equal to 0.7, tell me based on this sample what I should write.
0.7 to the power of 3.
0.7 is to 3.
Correct, because here success probability change, right? Into 0.3 square into what about this 0.5, right?
0.5.
Okay.
Sir, can you explain how did you get this last part, sir? P of S given P is equal to 0.7 into P of P is equal to 0.7.
Okay. So what is this P of S, right?
No, sir, not the derivation of the formula, the values which we are substituting. The below.
This one.
Yes, sir. Yes, sir. That one.
Okay. What is the meaning of this probability S given P is equal to 0.7? Means
P is given value
0.7, and what is the probability for our sample, right?
of sample. Yes, sir.
Correct. So in sample, how many times one is occurring?
3 times it is occurring.
So it will be 0.7 raised to power 3,
Okay, sir.
correct? And how many times 0 is occurring? 2 times. So it will be 0.3 raised to power 2, correct? And for this probability that P is equal to 0.7, it's a 0.5. Fine?
Yes, sir.
Okay, now, you can simply see here 0.3 cube 0.7 square into 0.5 divided by, we can take common something 0.3 square, we can take common, and 0.7 square and 0.5, right? So we will be having from here 0.3. So this will cancel out, this will cancel out, this will get cancel out. So and this will 1. So we got probability that P is equal to 0.3 given that S is equal to 0.3. Fine. Now we have to repeat the procedure for S. Sorry, when P is taking, what the probability P will take 0.7 given that S. Correct. We have checked for this. Since why we are doing, because it is asking about posterior mode and mean. So we'll see which one is the higher. Right. So for this case, what will the numerator part? You will tell me. What should I write?
P of S given P is equals to 0.7 into
Hmm.
P of P is equals to 0.7
Divide
divided
by P
the
of
new
S, right? So is it okay if I will write P of S this thing? Because anyway, we'll get the same thing, correct? You can see from here, right? P of S will get the same thing.
yes
Okay.
sir.
So I'm just writing the this term directly, this term. Okay. What about, okay? Tell me what about numerator part? Our samples is 11010.
0.7 whole cube into 0.3 whole square into
Correct,
zero
and
point 0.5.
0.5. Very good. Okay. And in the denominator, it will be
Sir,
0.3. Yeah. Yeah. Go ahead, please. Yeah. Someone is asking something.
no, sir, same thing. Whatever was above.
Okay. It's clear, right?
Yes, sir,
Okay.
yes,
Yeah.
yes.
0.5 will get cancelled out. This will get cancelled out, and this will be 1. So if you see what we got, 0.7, right? So which probability is higher?
0.7.
0.7, right? So so you can see from here, so probability that P will take 0.7 for the given sample, this is greater than probability of P is equal to zero point 0.3 for the given set, given samples. Okay. So what will be the my estimated value? So I can simply estimate, right? Okay. Or I will say we could estimate P hat as a zero point 0.7. This is posterior mod. Okay.
Sir, why we have taken this larger value, sir?
Which one?
This bigger value. Why did we take this bigger
What is
value?
the mod actually?
Okay, okay, fine.
Right? Mod tells us about maximum, right? Now, so next question is posterior mean, right? So how will you compute the posterior mean, right? Okay. So if you see how we can compute mean, it is something summation of x into probability, right?
Average.
Correct. It is something x into px. We are calculating something, right? If you see what is the p, p is unit discrete uniform 0.3, 0.7. Okay, correct. So can I write here? Okay, tell me what should I write the equation?
Mm, 0.3 multiplied by 0.7.
Okay, so 0.3 into
Sorry,
multiplied
sorry,
0.7. No,
0.5. 0.5.
no, 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 no. See, this is x into probability of x, right? So this x, px
So,
means what? What is the probability that p is
sample.
equal to 0.3 given sample, right?
Yeah.
Plus next value is 0.7 into probability that p will take zero point 0.7 given that s. Okay. Now I'm going to give you 1 minute to all of you. Just solve it and let me know the answer. And meanwhile, I will connect my laptop with the charging point. Okay. Just solve it and calculate the value. Okay. Okay, so Sumit has entered 0.58, Rajiv also 0.58. Let's see. I don't know the answer. Okay. Okay, so this value we have calculated, right? We
Yes.
got 0.3, right? If
Point
I'm not
three.
wrong. Correct? And this value 0.7,
Point
right?
seven.
So this will be 0.09 plus 0.49. Yeah. So 0.58 is the correct value. Okay. Yeah. Now, so okay, this one is okay for everyone. Correct? Yes, no.
Sir, how to get the conditional probability, sir?
This one with the help
Yes.
of Bayes theorem, right? We have just calculated. Okay. This is something we have done.
Oh, okay, sir.
Okay? We have used these values. Okay.
Okay.
So let's start with, let me give you some example, which is the something we are going to do in general. Okay. So I will take some distribution and some prior. Okay. Like when our prior is continuous, something like that. Okay. Now, suppose I'm just giving you, just taking one scenario. Hope that will help you to understand the concept. Suppose I'm saying x1, x2, xn, right? These all are samples from IID from Bernoulli P. Okay, I don't know this P. Correct? Suppose I'm saying I have prior information. This P is uniform 0, 1. Okay, this is the continuous uniform, right? Just make sure this is the continuous, okay, distribution. Fine. Okay. So if this is the case, so let's say our samples are, okay, small x1, small x2. These are the small x1. These are some values, some instances from the sample. Among these samples, I'm just assuming, see, if this is the Bernoulli, then 1 will occur sometimes, right? And 0 will occur, right? Yes or no? For example, I'm saying if 1 is occurring W times, then 0 will occur how many times?
N minus W times.
N
N
minus
minus
W.
W.
Correct? Great. Now, so see, you have observations, you have prior. So what is the next? We have to calculate the posterior. And what is the posterior says? What is the probability that I want to update my belief based on the given samples, right? This is something we have just discussed, correct? Or see, this is something we have done, right? What is the p given that what is probability of theta given that data proportional to probability of data given theta into probability of theta. So here theta means I'm talking about in general parameters. So here instead of theta I have p. Okay. Okay. So this is something we have to calculate, right? So what is this method tells us? So posterior distribution is nothing but proportional to the likelihood times prior, right? Yes or no?
Yes, sir.
So posterior we have to calculate. So what is the likelihood? What will be the likelihood from this? Likelihood means what is the chance of observing your samples, right? Okay. So what is the chance you will observe your samples? One is occurring W times. That means what? Okay, let me write if it's not okay. Hope that will help you. So this is something we have to do. Into prior is nothing but uniform 0, comma 1. Now tell me. So this means for a given P, what is the chance that x1 and x2, x1, x2 up to xn will occur? Tell me.
P to the W, sir.
Correct? P raised
W.
power W. Because in this sample, I'm just assuming one is occurring W times, right? We are talking here in general. So it will be P raised power W because P denotes the success probability, right? Yes or no? Into, or else let me do like this. That means P 111, how many times? W times, right? For 0, it will be 1 minus P, 2 up to 1 minus P. This will be how many times?
N minus
N
W
minus
times.
W times, right? Now, what is the distribution for this uniform 0, comma 1? It's a
Half.
1, 1, 1,
One.
right? It's a continuous. So PDF will be
Yes, yes.
1 upon 1 minus 0, right?
Yes, sir.
from here you got p raised power w 1 minus p raised power n minus w. Yes or no?
Yes, sir.
So here we got our posterior is proportional to p raised power w 1 minus p raised power n minus w. Maybe you have seen one distribution called beta. So there is one form if I'm saying x is following beta distribution with parameter alpha and beta, then the PDF of beta will be proportional to actually it will be proportional to x raised power alpha minus 1 into 1 minus x raised power beta minus 1. Okay, so there is in the denominator you will get term of like gamma alpha plus beta, that is where we are ignoring, that's why we are using this proportional sign here. Okay, so this is something. So is this form like this?
Yes, sir.
Correct. Here if you see this p is not a constant, this is a random variable, right? So can I say here this posterior is nothing but, okay, first of all it should be alpha minus 1, right? If you see alpha minus 1 beta minus 1, so can I write p raised to power w plus 1 then minus 1? It should be alpha minus 1, then I can write alpha, right? Beta minus 1, then I will write beta. Yes or no?
Yes, sir.
So can I write in here n minus w plus 1 minus 1? Can I add 1 and subtract 1?
Yes, sir.
Correct. So what I will get from here? So can I say my posterior distribution is nothing but what? Beta
Beta w
distribution
plus
with
1.
parameter w plus 1
W.
and n minus
N minus
w
W.
plus 1.
plus 1.
So far so good.
Yes,
And
sir.
here the mean here is posterior mean nothing but alpha divided by alpha plus beta in case of here. Okay. So this is not a division sign, this is just a different thing. This is the mean. Alpha divided by alpha plus beta. So if I will ask what is the posterior mean for this case, so what it will be? It will be w plus 1 divided by alpha plus beta. So w plus 1
N plus 2.
plus n minus w plus 1. W will get cancelled out. I will be having w plus 1 divided by n plus 2. Is this clear?
Yes, sir.
Correct? So should I take another example, another prior?
Yes, sir. Yes, sir.
Let's here our prior was uniform. Let's take second thing with the same scenario. I mean, I'm saying x1, x2 up to xn. This is the Bernoulli with p, and I'm saying I have the prior. This p is nothing but here beta itself with parameter alpha comma beta. Okay. Now, main question is I have to calculate the posterior distribution. Okay. So posterior distribution will be here, and we know posterior nothing but likelihood, okay, times prior. Fine. So what is the likelihood here? It will be, tell me. Just assume 1 occurs w times, okay, and 0 will occur then n minus w times. Now tell me what will the likelihood? Likelihood means, so I'm talking what is the probability that observing your samples for a given p into probability of p. Now tell me. Now you will tell me, I will write the steps. What should I write here? For likelihood first.
P to the power W
P raised power W file.
into 1 minus P to the power N minus W.
Okay. And what about this P of P?
P to the power W minus
Anyone?
1. P to the power W minus 1.
Why W minus 1?
Actually, sir, it's a beta distribution.
Beta distribution with parameter alpha and beta.
Oh, alpha minus 1.
Sir, I have
Alpha minus 1.
So alpha minus 1
Alpha minus beta.
into
1.
1 minus P.
beta minus 1. Correct?
Yes,
Okay.
sir.
sir,
Yes.
sir,
Yes.
sir, in the means in the formula we divide by P of S also, right? But in these type of questions we don't divide by S. Why so?
Yeah. Actually, we are dividing by S and we are taking equality signs. Okay. If you see this S, basically it's independent of your parameter, right? Basically, this is a constant value, correct?
Yes.
Okay, that's why we are taking here rather than using this equality sign, we are using this proportion sign, right?
Proportions.
And this
So sir, we don't need to
this
divide by s then.
sorry.
So after taking this proportion sign, we don't need to divide by s.
See, there is a difference between this proportion sign and equality sign. If you're taking equalities, that means you have to take everything, right? Including constant and all. Here, our focus is on parameters, right? On the form. So that's why we are taking we are basically focusing on the unknown, these parameters, right? This random variables and all. That's why we are using this. Every constant will merge here, actually. You can simply say in a simple term. Okay? We are not using that P of S, divide by P of S. Okay,
Yes.
if you wanted to use, you can use, but it will be equality sign, but that will just increase your I mean difficulty of okay, difficulty. Okay, so that's why, see, in the beta distribution, if you see, if I'm saying x follows beta, alpha comma beta, if you search on Google or everywhere or something, so PDF is normally it will be f of x equal to x for alpha minus 1
Yes, sir.
into 1
Into
minus x
1
plus
minus x
beta
to
minus
beta
divided by gamma of
minus.
alpha plus beta. But we are not taking that constant. That's why we are using this proportion sign. Okay. Now, so if you see what I will get from here, p raised power alpha plus w minus 1, right?
Yes, sir.
And 1 minus
And
p
1
raised power
minus p to the power n
n
minus
minus w
w
plus.
plus beta minus 1.
Okay. Okay. So is this form of again beta distribution or not? Yes or no?
Yes, sir. But how do we know, sir?
That
It
is
is a
something you have to
beta
keep
distribution.
in mind, actually. Okay. Just like you know the form of exponential distribution, right? You know the PDF of uniform distribution, right? Okay. Something you have to see. So this is something. Okay. Tell me, this posterior distribution is again beta. Tell me what is the parameters here?
Alpha plus W.
Alpha plus w.
Uh,
Here it is n minus w plus beta.
Correct. Very good. And what will be the posterior mean?
Alpha plus w plus n minus.
Divide by C. Posterior mean is nothing but alpha divided by alpha plus beta. Alpha divided by alpha plus beta. So instead of
Okay,
alpha,
sir,
you
got
alpha
it.
plus W.
N plus alpha
Yes, sir, got it. Alpha plus w plus n minus w plus beta.
So W will get cancel out. So you will
Alpha
get
plus beta plus n.
alpha plus, sorry, N plus alpha plus beta. So now agenda is clear. Yes or no?
Yes, sir, got
How
it,
to
sir.
do the things, right? Okay, let me give you one question. Just do this. Okay, or else, okay, just I will give you some 5 minutes. After that, we will solve. Okay? I will see the answer. Okay. Everyone have pen and paper, right? Let's say one
Yes,
zero
sir.
zero 110. Let's say 111 again 0. So 336 410. These observed samples are from Bernoulli P. Okay. Now what I'm saying, I have a prior P. This is from beta. Parameters are, let's say, half. Okay. Now, so just calculate the posterior mean. Okay. I'm going to give you some 3 to 4 minutes. The same thing we have done. Okay. In general, now you have to tell me. Okay. The thing is that I can do right now, but just why I'm asking to all of you, because you should gain some idea, right? How to do this. Okay. Okay. So do let me know once you will complete.
Sir, I got 0.59.
Okay. So you directly applied the formula.
Yes, sir.
Okay. So I wanted to, okay. No problem. What about others? Are you trying?
Yes, sir.
Okay, fine, fine.
So is the Bayesian estimation is done?
Yeah, we are just solving some problems related to that. Why? What?
Yes, sir, got it.
Yeah. Abhishek also got 0.59 and Shivam also got. Okay, let's see. Should we proceed or any one of you is trying? Then we can wait. Yes, no?
We can solve.
You can? Okay. Fine. So simply we know what is the posterior is nothing but proportional to the likelihood times prior, right? Now, what is this likelihood? We know the same thing. What is the probability that observing your samples x1 up to xn, given that p, okay, into f of p, or you can say p of p, anything. Don't just one thing we need to take care whether it's a discrete or one. Okay. That means what? If you see what is the p, so this samples, right? Basically, correct? Means 100 110, correct, 1110 for a given p and f of t. Fine, this is something we have to do. So what is the next? So how many times 1 is occurring? 1 2 3 4 5 6, right? So
6,
it
yes.
will be p raised power 6 into 1 minus
1
p raised
minus
power.
p to the power.
What about this f of p? This is the prior, correct? So it will be, tell me, what should I write?
1 by 2 to the power 6.
1 by 2 raised power 6. Why? This is the beta, not a Bernoulli.
Okay. Only 1 by 2.
1 by 2 minus 1.
P raised power 1 by 2 minus 1, right? Into 1 minus p raised power, again 1 minus 1 by 2 minus 1. Yes or no? Right? So
Yes.
what I can write, I can simply write p raised power 6 plus half minus 1 into 1 minus p raised power 4 plus half minus 1. Yes or no? Correct? And we know, if x follows beta distribution with parameter alpha beta, then what will the PDF? PDF will be proportional to x raised power alpha minus 1 into 1 minus x raised power beta minus 1, right? So here, can you tell me what is the alpha and beta? Then I will say posterior distribution will be, it will be
Alpha
beta,
is 6 plus half,
Plus half.
and beta is
4 plus
4
half.
plus half. Half.
correct? 4 plus half,
Half.
right? That means it's basically I can simply say it's beta 6.5 and 4.5. What is the posterior mean?
6.5 upon 6.5 plus 4.5
Correct? And this is nothing but
is
6.5 divided by 11, right? Which is nothing but 0.5.
5.9.
Correct? Is this clear to all of you?
So if there is post posterior mode, then
No, sorry, this distribution and all, we are talking about this mean itself, okay?
Sir, how can we directly find with formula this?
Which
The
one?
last question. Yeah, this last question.
This one?
Yeah, yeah.
Actually,
Directly.
I think you didn't focus. See, I told you if x follows beta distribution with parameter alpha and beta, right? Then form of the PDF is this: fx will proportional to the x raised power alpha minus 1 into 1 minus x raised power beta minus 1. The mean of this beta distribution nothing but alpha divided by alpha plus beta, right? Alpha means first parameter, beta means second parameter, okay? Alpha divided by alpha plus beta. So by once we have solved, if you see, so this is your alpha, first parameter. This is your beta. So mean is what? I told you alpha divided by alpha plus beta. So alpha divided by alpha plus beta. Got it?
Got it. But
Yeah.
we have to find alpha and beta first,
Yes.
then
Yes.
only we
Yeah.
can find.
Yeah.
We cannot find it with this formula alpha plus W upon N plus alpha plus beta.
No, you can find it's not a problem. See, if you see what is the how many times W is there, you can simply then you have to memorize the things, right? But I
Okay.
don't want. I mean, you should memorize the thing, and because
Oh,
sometimes it's good to go with the procedures. But if you
okay.
remember, it's good, not a problem at all. Okay. So in this case, you are saying this case, right? Alpha
Yes.
plus W, right?
Yes.
Divided by N plus alpha plus beta. So what is the alpha plus W?
Alpha is and W is 6.
W is 6. And what is the alpha? Alpha is half,
Yes.
correct? And
Yes.
N plus alpha plus beta. So if you see alpha plus beta is again a half plus half. That is 1.
1.
And
1.
N is 10. So 6.5 divided by 11, right?
Okay.
The same thing we got. You can do it. You can do directly itself. Okay, no problem. So what about this question number 1? Let's see this very first question itself. How many of you got this as a correct, or how many of you attempted, or 1 and 2, or you didn't uh, attempt till now? Yes, no, you can simply raise your hand, right? I'm not. You can simply tell me whether you attempted or not, or you got the idea or something like this.
Attempted but did not get, sir.
Okay, what about others? Yeah, you can
Didn't
simply
have.
say, see, if you, okay, let me clarify something from my end. If you'll not speak, right, anything, either you got as, no, something like that, I will simply assume you are getting the idea, right? And we can discuss and we'll close the session, okay? So it's good to go, good if you can simply tell me, right, you didn't attempted, or you attempted, or you didn't get that, something like that. You can simply, right,
Not
you have the
attempted.
system, you can unmute yourself, you can raise your, you can chat box. Lots of ways are there, okay? Okay, so I got most of them didn't attempted. Okay, let's then let me do. Okay, let's do the question itself. It's activity 10.3, question 1. Okay, so I am doing because it's a little bit different. Let's see whether what is the. So if you see here, x is the discrete random variable 0, 1, 2 with respective probabilities p by 3, 1 minus p, 2p by 3, right? So I'm saying x is the discrete random variable with value 0, 1, and 2 with respective probabilities are p by 3, 1 minus p, and 2p by 3, correct?
Yes.
Now, this p lies between 0 and 1. And this is the one condition. Of course, this is the probability. And some samples are given to you. 2, 1, 1, 0, 0, 2. So samples are given to us 2, 1, 1, 0, 0, 2, then 1, 2, double 0. Okay. Then prior is uniform 0, comma 1. So it is asking posterior distribution of T. Okay. Okay. So make sure you may get the, if you seen the PYQ and all, you may get the questions something similar to this. I mean, similar to this pattern in your exam, right? There will be some posterior distribution, then posterior mean. Okay. So prior is uniform 0, comma 1. That's P is uniform 0, comma. This is the continuous uniform. So question is you have to find the, okay, what will this f of P? This is continuous. It will be 1 upon B minus A. That will be 1 minus this is 1. Correct?
1.
No. So what is the posterior? Is proportional to likelihood times prior.
Prior.
Right? Now,
Yes, sir.
what is the likelihood? Probability that
P to the power.
observing your samples, right? For a given P into f of P. Now, let's do. Now, what is the samples? Samples are, okay, let me write down here again samples. 211 002 1200. 211 002 1200. And what is the probability for 0? It's a P by 3. Correct? Okay. Tell me what should I write then? For 0, probability is P by 3. For 1, probability is 1 minus P. For 2, probability is 2P by 3. Tell me what should I write then? This is observing your samples. For Bernoulli, we have done, right? For 1, we are just like taking, we are just simply multiplying how many times 1 is occurring, right? So what
P
should
by
I do
3 to
here?
the power 4.
Sorry?
P by 3 to the power 4.
Correct? Yeah. Because this is the something we have to observe my samples, right? How many times 0 is occurring? 4 times, right? So I will write P by 3 raised power 4 or not? Is this okay? Because P by 3 into P by 3 into P by 3, right? So in likelihood, if you have seen in week 9, what we are doing, we are multiplying product of I is equal to 1 to n fx I of theta, right? Yes or no?
Yes, sir.
So here, how many times 0 is occurring? 4 times. So I have to
4
multiply
times.
4 times for the respective probabilities or not, correct? For 1,
Yes.
Speed power 3.
so 1 minus p raised power 3. For 2,
2P by
p by
3
3 raised
to the
power.
power 3.
So far so good. And what is this prior? It's a 1, correct?
Yes, sir.
Correct. Now what we'll get from here? Can you tell me? So it will be p raised power 4 divided by 3 raised power 4, 1 minus p raised power 3 into 2 raised power cube, p cube divided by 3 cube. Since we are using proportional sign, right? So I will just ignore all the constant value. I will focus on p raised power 4, 1 minus p raised power 3 into p raised power 3. Yes or no?
Yes,
So what
sir.
we'll get here? 1 minus, 1 minus
P
p
power
raised power
7.
3
P to
to
the,
p raised power
P to the
7.
power 7.
What is this form? Something, is this
Kernel.
Bernoulli or something else?
Beta, sir.
Beta, correct? So can I write?
Beta.
Because we know
6,
form
2,
x
sir.
follows beta, alpha comma beta, then PDF is proportional to x raised power alpha minus, this is proportional sign, into 1 minus x power beta minus 1. It should be alpha minus 1. So should I write p raised power 8
6.
minus 1? Not 6.
Yes.
Why 6?
Yes, yes. Got it.
And 1 minus p raised
8.
power 4 minus 1, right? Can I write?
8 and 4.
Correct. So what is the posterior distribution now? So it will
Beta
be
with
beta
parameter
8
8
comma,
and 4.
yes or no? So I think first option is the correct. You can see 7 and 4 is also given to you. Okay, 7 and 3 is also given. Sometimes I mean, people make mistake. They will simply say 7 and 3. They will click beta 7 and 3. No, we have to be clear with alpha minus 1 and beta minus 1 scenario. Is this fine? Next
Yes,
question is
sir.
posterior mean. So what is the posterior mean?
7 upon 10.
7
See,
upon 10.
sorry, sir. No, sir. 8 upon 12.
4.
The same mistake, right? So it will be 8 divided by 12. That means 4 divided by 6. That is 2 by 3, which is 0.67, right? You can check whether it's what is the value. So beta 884 is correct, which we have which got the same answer, and 0.6, and it's inside the range. Okay. Okay. Fine. Is this clear?
Sir,
Yes,
one
sir.
small doubt, sir.
Yes.
There is confusion between binomial and this beta, sir.
Why confused? I mean, where you are getting
Because
confused? Hmm?
because I was confused that if it is proportionality, sir,
Hmm.
then NCK part is taken away, and this is in the similar form of p to the
Hmm.
power k and 1 minus p to the power n.
One more thing. One more thing. First of all, just be clear. What is this? This is continuous or in discrete?
Yes,
It's a continuous, right?
yes.
Correct. Now, is it okay?
Yes, sir. Then,
Binomial is a discrete case, right?
sir, if it is continuous, then it cannot map to discrete, and if
Yes.
discrete, then not to map.
Correct.
Cannot map to continuous.
Yeah. So that's the, if you see beta is for continuous case. Okay.
Yes, sir.
Okay. Is it okay, right? Are you getting? See, your
Yes, sir. Now clear, sir.
yeah.
Because I will not clear that if it is continuous, then it cannot map to
Yeah.
this discrete.
Fine.
Okay,
Yeah.
sir.
Yeah. So okay, is this fine? Did you get the idea? Overall idea?
Yes, sir.
Any doubt?
No, sir.
No. Is there any question? Any activity, or do you want to solve any other question? Or is it fine?
Fine, sir.
What about this geometric case? I can. Is it okay? Or should we do?
Sir, do sir this question.
Okay. So what I will do, I will not do for this particular sample. I will do in general. I mean, I will take this geometric P. I will take this prior. I will do in general. That will be fine. Okay. At the end, see, you have to just do for this case for these five samples. I will do in general. That will be okay. Correct.
Yes.
Okay.
Okay.
Okay. Fine. So let's just take the scenario. So I'm saying x1, x2 up to xn. This is IID. That's a geometric P. Fine. This P is unknown. And I'm saying I have some prior, and this P is nothing but continuous uniform with 0, comma 1. Okay. Now, we have to find the posterior. Okay. First of all, you can you tell me if x follows geometric P. I'm talking in general. Then what is the probability that x equal to k?
P to the power k into 1 minus p to the power k minus 1.
Just repeat your statement again carefully.
P to the power.
Sorry.
P to the power
P,
k.
P into 1 minus P to the power K minus 1.
Yeah, why P raised for K? See, that's why I told, right? Don't memorize the thing. Just try to understand what is the, when we are using the geometric, what geometric tells us.
Kth one is the success one.
Correct? We are getting the success at the kth, right? Try.
Yes.
That means till K minus 1, I will get the failure, right? Failure means 1 minus P raised for K minus 1 into P.
Into p.
That's all.
Yes.
Rather than memorizing something random, it's good to go with the concept. Okay. Okay. So this is the case. Suppose what about P probability x equal to x1?
1 minus p to the power x1 minus 1 into
Into
p.
P. If I have sample x equal to x2
Then replace with x2.
into P, right? Something like that. And so on, probability that x equal to xn, then it will be 1 minus P raised for xn minus 1
xn
into
minus
P, right?
1 to
Okay.
p.
Let's
Yes.
focus here. Now, so we know we have done till now posterior nothing but proportional to likelihood times prior, right?
Yes.
And we know what is the likelihood probability, what is the chance that observing my samples for a given value of P into f of P, or this f of P is distribution of P. This P is 1. f of p is 1, this because we know this is the continuous in form, right? Now what it will be? It will be just a multiplication of all these things, right? Yes or no?
Yes, sir.
Basically, what we have to do, we have to multiply all these things, right? Means p into 1 minus p raised to x1 minus 1 into p into 1 minus p raised to x2 minus 1 up to p into 1 minus p raised to xn minus 1 into 1.
Minus.
So far, so good?
Yes, sir. Yes, sir.
No. Proportional to, it will be p raised to n, right?
Yes, sir.
And
Yes,
1
sir.
minus p raised to it will be x1 plus x2 plus up to xn minus
Xn.
n, because if you see minus 1 minus 1 minus 1, it will be n times,
James. Yes.
correct?
Yes, sir.
Right? Proposal p raised power n, 1 minus p raised power, this is something I can simply write summation of xi minus n,
Yes, sir.
correct? Now what is this? This is something, can you tell me what is this? Is this
Beta.
beta of what?
N
Again,
minus 1.
N minus 1
no, why n
into
minus 1?
N plus.
Okay, okay. I'm going to write the form of beta now. Then you will tell me what is the, what should be alpha and beta. So fx is proportional to x raised power alpha minus 1, 1 minus x for beta minus. Now, tell me what should I write?
Plus 1.
N plus 1 minus 1, right? See, we have to fulfill this condition, right? It should be n at the end. Yes or no?
Okay, sir. Got it.
So 1
Yes.
minus p raised power summation of xi minus n, I can add 1 and subtract 1. Correct? Is this
Yes.
clear? Then it will be
Yes.
alpha and then it will be beta, right? So
Alpha
now
will be n plus 1 and beta
I
will
have
be
posterior distribution as beta n plus 1 divided by, beta and summation xi minus n plus 1. Yes or no? Correct?
Yes.
So what is the posterior
Yes, sir.
mean here?
And
N,
n plus
N
1
plus
upon
1
n
divided
plus 1 plus summation of xi minus n plus 1.
Okay, now summation of xi minus n plus 1 or something else also,
Plus n plus
Plus
1 also.
one, sir.
because alpha plus beta is also will be there, right? Denominator.
Yes, sir.
So n will get cancel out. What will get? N plus 1 divided by summation of xi plus,
Xi 2.
correct? Now if you see, now let's come to that question. In that question, what is the samples? 241, 24513, right? Correct? So samples we have 2,
2,
4,
4,
5,
5,
1, 3. So
3,
what is the
4,
value of n here? N is 5.
5.
5.
So this is your x1, this is your x2, this is your x3, this is your x4, this is your x5. So what will be the posterior mean here? Can you tell me? So
6
6
5,
is
upon 17.
17.
6 upon 17
so it's a 15 plus 2, right? Yeah.
plus 2.
6 upon 17. So what is the value?
17.
Can you solve this?
So 0.35.
0.35. Let's see.
35.
Yeah, so 3, 5, is that 3 digit or not? I think 3 digits will be there. 3, 5, anything else?
2.
2, right?
2.
Yeah, that's why it's in the range. Okay, now it got it. Okay, so now main idea you got it or not? It like this likelihood times prior and all rather than something, correct? Okay, is this clear?
Yes.
Fine. Any doubt? Anything else? You got the idea of this week 10?
Yes.
Okay, fine.
So can you please, I have a doubt in the concept of week 9,
Which topic?
method of movements
Where your doubt?
in the whole topic. Sir. How to
In
do
the,
question on that? Whole topic of method of movements.
okay, had you attended the
Estimation.
week 9 sessions or not?
Yes, I attended.
So you're doubting method of movement itself, right?
Yes, sir. If you do a question on that, it will be helpful.
Okay. So should I take some random or should I take from activity?
Random, sir. Random.
Random. Okay. I mean, random means I need to. I should derive from any distribution or something like that.
Distributions.
Distribution. Exponential is fine.
Yes, sir. Good.
So okay. So we have discussed the week 10 concept. Okay. Hope. Okay. Can you confirm? Did you get the idea right? Everyone got the idea how to do the questions. Now, will you able to do the questions related to those topics? Right?
Yes, sir.
Yes, sir.
Yes.
Okay. So in method of moment estimation, so what we are doing, suppose I'm saying I have samples x1, x2, xn. I'm just taking some very simple example. Let's say I'm talking about IID exponential and parameter is lambda. I don't know lambda, I have to estimate. So since this is a single parameter, right? Okay.
Yes, sir.
So I have to equate very first moment itself, right? I mean, I have to do the m1 equal to expectation of x, right?
Yes, sir.
If you have two parameters, you will use two equations, right? See, in general, in mathematics, what we are doing, if you have one unknown, you need only one equation, right? One unknown means suppose you have, I'm saying a plus 3 equal to 5, then find the value of a. You need only one equation, right? If I suppose
Yes,
there are
sir.
two equations, a plus 3 equal to 5 or b plus 3 equal to something else, tell me the value of a and b. Then you need two equations, right? That's why
Yes, sir. Got it.
if you have two things, then I need to take two moments. Otherwise, else one moment. So it's a one. Okay, what is the first of all this expectation? This is the distribution mean actually, or population mean. So what is the distribution here? Exponential lambda. What is the
1 by
expectation of x?
lambda.
1 by
1 by lambda.
what is the
Lambda.
m1?
1 by lambda.
M1.
N divided by x1 plus x2 up to n.
See, if you
N
see in the
divided.
lectures, we are just simply telling mk
Ah,
1 by n, right?
now
Summation
summation.
of I is equal to 1 to n xi raised power k, right? Here
Yes.
I'm talking about only one, m1. So m1 will be 1 upon n summation I is equal to 1 to n xi. Okay,
Yes, sir.
Yes.
correct. So what we are doing,
Yes.
I told just few minutes before we due to weak law of large number, we are equating m1 equal to expected of x, right? This is the sample moment. Okay, sample moment, the values, this is the distribution moment. Okay,
Yes, sir.
now so if you see we got summation of xi divided by n equal to 1 by lambda, and we know we are interested to know the value of lambda. So lambda hat will be n divided by summation of xi. Fine. So whatever xi is given
Yes.
to you, I mean, for example, suppose I'm saying there are 2, 3, 0, 1, and 2, and then estimate the lambda of lambda cap. Then you can simply apply
Add.
this formula type.
Yes.
Okay. Or else
Yes, sir.
let me do one problem from activity. I think then that will give you more idea. Then we can method of moments. There are problems in activity 9.5. That will help you. Just a second. Okay, let's see very first thing. Okay. So saying consider sample 210, 220, 225, 217, 210, 210 drawn from a distribution with unknown mean mu. Find the estimate of mu. So what you will do here? Mu is what? Here mean, right? So this
Yes.
mu cap is equal to nothing but sample mean. You have to add these all observations and divide by
Average.
6.
Yes.
Okay. Let's do this one, second one, that will help you. Okay, that. So if you see here, a continuous, I mean the PDF of a continuous random variable is given to you, 1 plus theta x divided by 2. Okay. Question is, see, rather than, if you see here, I'm saying x is from exponential distribution, right? But in that case, x is not from any particular distribution. It's saying, question 2, it says x is continuous distribution with PDF 1 plus theta x divided by 2, right? So here it's not any particular from any particular distribution, right? It's saying x1, x2, xn be IID samples of an estimator of theta by the method of moments. Okay, are you getting idea? What I'm saying?
Yes, yes.
This is the IID samples. Okay, okay, and we have to estimate the theta. So what we have to do first of all, just be careful. This is the single parameter. Then I have to equate m1 equal to expectation of x, right?
Yes, sir.
This m1 is what? 1 upon n
Summation.
summation of xi, and this expectation of x, how you have to compute? Since in the previous question it was exponential distribution, right? Then you can simply told expectation of x is 1 by lambda because you know. But here you don't know, right? Then this expectation of x
We
we
have
have to
to
calculate,
integrate
correct? So expectation of x is nothing but it will be integration
integration
of -1 to 1
minus
x
1 to 1
into,
x into fx.
correct? If it is discrete, then you have to do the summation.
Yes, yes.
Correct? Now,
Got it.
so it will be 1 by 2 minus 1 to 1 x 1 plus theta x dx. Correct? Next, it
Yes.
will be 1 by 2. I can simply do minus 1 to 1 x dx plus theta
Plus
minus 1 to 1 x square
x
dx.
square.
Correct?
Yes.
Now, it will be 1 by 2 x square by 2
Square
minus
2
1 to 1 plus theta x cube
x cube
divided by
upon 3
3 minus 1 to
is
1.
equal
Fine.
to 1.
It will be half and 1 by 2, right? Then 1
Plus half. Plus half.
plus 1. Correct? 1 plus 1.
Yes.
Am I correct? Or...
Yes, sir.
No, sir. 1
Yeah,
by
1
2
square.
plus 1 by 2.
No, no,
Then
no,
1.
no. One second. It will be 1 square minus of minus 1 square. It will be 0, right?
Zero. Zero.
It will be 0.
Yes, sir. 0, 0.
Basically, it will be 1 minus 1. Correct? Plus theta by 3, 1 minus, it will be again minus 1. Right?
Yes, sir.
This is correct, right? 1.
Yes, sir.
It's
So it will
correct.
be half and it will be 2 theta by 3, right? This will become 0. So we'll get theta by 3, correct? So we
Yes, sir.
got expectation of x as a theta by 3. And what
3
we have to do, as per the method, I will equate m1 equal to expectation of x.
x.
M1 we know 1 upon n summation of xi is equal to theta by 3. So
3
theta hat will be 3 by n summation of
summation of xi.
xi. If you talk about in general, I will use the capital letter, right? That is something you can do. 3 by n summation of xm is x1 plus
x1,
x2
x2,
plus. Is there any option?
xn.
3 by, yeah, B option is the correct. Okay. Is this clear?
Yes, sir. Got. Yes, sir. Clear, sir.
Oh,
Thank you, sir.
fine. Yeah, thanks.
Sir, I have also doubt in two questions, activity questions, sir.
Where 10
In
or
week 9, sir.
which activity?
Activity question 9.6, activity 9.6, question number 2.
Activity 9.6. Okay, what is doubt here? Hello.
Sir,
Yeah, what is your doubt here?
how will I find the value of n? I am unable to proceed with this example.
Okay, have you done? Okay, in case of actually in uniform, right? What is the okay? What is the answer? Answer is the 20, right? I'm correct. Answer you are getting 20 or something else?
Sir, I could not solve it actually, this question. I could not understand the logic behind it.
See, can you see my screen? No?
No, sir.
Okay, fine. So, 1 second. Now can you see my screen?
Yes, sir.
No problem. Okay, just a minute. Okay, so if you see, okay, let me talk about in general first of all for the uniform. Okay, what is the answer? It will be 20 is there, right? Okay, okay, okay. I got. Okay, fine. Let me tell you in general first of all. Suppose I'm saying x1, x2 up to xn. This is IID uniform. Okay, this is the discrete 1 to let's say up to n. Okay, fine. What is the each probability for each xi? It will be 1 upon n, right? What's discrete? Yes or no?
Yes, sir. Yes, sir.
Correct? Okay, so let me talk about in general. So it's about ML estimation, right? Yeah, maximum likelihood. Sorry, in maximum likelihood, what we have to do? Tell me. What we are doing in likelihood? We are just multiplying with each thing, right?
Yes, sir.
Basically, we have to multiply with each probability, right? So it will be 1 upon n into 1 upon n into up to 1 upon n, right?
Yes, sir.
So what you will get at the end? 1 upon n raised to power n, correct? Where your xi is nothing but up to 1 to n, right? It is taking all these are discrete point, right?
Yes, sir.
Or else it will take value 0, correct? This is something. Now based on this thing, okay, let's take some another thing here. Instead of small n, it will create confusion. Let's say it's taking value some theta itself. Okay, it will be theta, it will be theta, it will be theta. Okay, let's erase this theta itself. Let me take this is capital N thing. It will be 1 upon capital N, right? Yes or no? Then it will be 1 upon capital N raised to power small n, right? Basically, correct? Okay. So far, so good. Are you getting my idea?
Yes, sir.
Okay. Now tell me, so in maximum likelihood, what we are doing? Here we can't do the rest procedure, right? Because this likelihood is nothing but u of just 1 upon n raised to power n, where x belongs to 1, 2 up to n, right? This is the discrete case, right? And 0 otherwise. This is the only two case you have, correct? Now tell me when it will be maximized, maximum value. When you will get this maximum value?
When n is infinity.
See, when this will be maximum?
When n will.
When small n becomes 0, sir.
Yes.
When
N will be minimum.
Minimum. Just think a little bit. See here, you can simply say here your capital N is what? This is known to you or unknown to you? This is unknown, right?
Yes, sir.
This is something we have to estimate. I'm just see, I'm just asking to you so that you can just think a little bit. Tell me when I can maximize this. Are you getting my idea? What I'm trying? Can I say anyone, any thought when you will get this maximum? What about n? Well, this is something we see. Is there anything we can differentiate or something? Right? No. Okay. So here you have to just think because this is just a single thing. Okay, tell me in likelihood, maximum likelihood, what we are doing. First of all, I will come to this point and
When small n tends to
okay, tell me
when
in maximum likelihood, what we are doing. We are finding likelihood something, correct? Yes or no? Then we are finding log likelihood, correct? Then we are differentiating this log likelihood with the parameters and we are equating with the 0 to get the maximum value. Yes or no?
Yes, sir.
Correct. Why we are equating to the 0? Because we know this log likelihood we are going to maximize, right? So maximize means the second derivative should be less than 0. I mean, why we are equating to the 0? Because suppose this is your function, so slope should be 0. Suppose this is the maximum point. At this point, your slope will be 0, right? That's why we are equating to the 0. Now tell me when and then when it will be negative. After that, it will be negative. First of all, tell me when it will be equal. I mean, to equate it 0 or to get the maximum value, what this n should be.
Sir, we are maximizing, trying to maximize L, no?
Correct.
So N should be maximum, minimum, sir.
You want to maximize. Okay. You want to maximize L. That's okay. After maximize, what we are doing? Del log L should be 0.
Yes, sir.
And after second derivative should be less than 0, right?
Yes, sir.
Correct. So what should be the value of n? I'm just think a little bit. When it will be differentiation, you can equate it 0, or when it will be maximum. Okay. First of all, tell me what is our agenda? Our agenda is I want to maximize, right, 1 upon n raised power n. Right?
Yes.
Correct?
Yes, sir.
Now, what should be the value of n you should take? You can take directly itself. Just think, whether it should be maximum or minimum. I gave you the idea. Whether it will take maximum or whether it should take minimum. Just tell me.
Minimum.
It is the negative values.
Tell me whether it should take minimum or maximum.
Minimum, sir.
Okay. What about others?
Minimum, sir.
Negative values, so we should minimize it.
So, why negative and minimize? What do you mean?
Because we are trying to maximize, and if it is negative, so it should be minimized.
Actually, sir, the whole expression will be maximized if n is minimum.
Okay. N should be 1, so argument is max. Okay. Aditi is saying n should be 1. Okay, fine. Okay, I told you one more thing. Likelihood should be, we are equating that differentiation equal to 0 also, right?
Yeah.
Okay, I'm telling you it should be the maximum. Now tell me how. It will be n cap will be maximum. Can you tell me how? Basically, it should be n should be maximum of any x1, x2 up to xn. Now, can you think how? Yes, no? Yeah, any thought? Any thought? Why I'm saying this should be maximum? Let me take one example here. Suppose I have some observations, let's say 3, 4, and 5 itself. Okay, these are the x1, x2, x3. Okay, so tell me the which value, I mean, what will be the likelihood for this case? Your likelihood your likelihood this case, right? N raised power n. Fine. I'm saying likelihood this your likelihood 1 upon capital N raised power n. Now tell me what will be the next thing. So it will be 1 upon
Capital N, 3 raised to 3.
raised power 3.
And yeah, sir. Capital N, capital N is 3, no, sir. And small n is 3, 4, and 5.
No.
It's not like
Actually, see, if you see for this case, according to you, it should be 3, right?
yes, sir.
I think it is going to little bit confusing for you. Let me start from a freshers. Okay, I think Rajiv, you asked right question this one.
Yes, sir.
Okay, did you get this one or not?
No, sir.
No, not at all. Okay, no problem. Let's do. Suppose what we are doing. What is our PDF? It will be fx of 1 upon n, right? For each xi, right? X equal to xi whenever whatever I is, right? Yes or no? Or else it will take value 0. This is the what is the likelihood? It's the likelihood of x1 up to x2 up to xn, right? Of your n, right? It will be 1 upon n raised power n, or else I will say n raised power minus n. Correct?
Yes.
So what is this n hat? N hat means what? The estimation of this. So what is this? I have to find the maximum of this likelihood. Yes or no? That means maximum of this n raised power minus n. Capital N raised power minus n. Correct? Yes or no?
Yes.
So now just think when I'm good, I will get the maximum. I told you, right? When I will get the maximum, suppose our likelihood function is concave, right? Then to get the maximum, slope should be 0. Yes, no?
Yes, sir.
Now think a little bit and tell me, let me know. First of all, this is a decreasing function or not? See, 1 upon n raised power n, it is a decreasing function of your n.
Yes, a decreasing function.
It's a decreasing function, right? Now tell me, with the estimate will be it will be the smallest possible value of your theta, or theta means I mean your capital N. Okay, first of all, this is the decreasing function. Yes or no?
Yes, sir.
If it's a decreasing function, right, the estimate, okay, the estimate of n, or I will say estimate will be it should be smallest possible value. If it's a decreasing function, you should get the smallest possible value, right, to maximize this, right? Yes or no? Are you getting? See what I'm saying? We have to maximize this, right? To maximize this, the estimate will be the smallest possible value or not? Yes, no. Are you getting what I'm trying to say? It should be the okay. Here, it should be at. I mean, it should be least possible n, right? Yes or no? Least possible n.
Yes, sir.
Correct. That means that is something I'm talking about. Smallest possible value of n. Yes or no? Are you getting here? What?
Yes, sir.
Yeah, it is okay. I'm talking about the estimate will be the smallest possible value of n or not, and this n will be such that it should be greater or equal to xi or not. Now tell me, it should be greater or equal to xi or not. This n cannot take, you can't take as a zero, right? This n you cannot take as a zero.
Yes, sir.
Okay, so this greater or equal to xi means what? This simply means I need to take n hat ml as a nothing but maximum value of each xi.
Okay, sir.
It means n will be minimum, but it will always take the value greater than xi, all xi,
Yes, see, okay,
greater
okay.
than equal to.
Just focus this statement on this. The estimate will want smallest possible value of n such that n should be greater or equal to xi, right? Okay, first of all, your parameter. Okay, first of all, let me tell you, this n it should be greater than zero. Fine.
Yes, sir.
It should be greater than zero, right? And your each xi will be lie between 0 and sorry, 0 and I, not 0 and I. It's sorry, it's a discrete.
Sir, I have a question here. Why n should be greater than greater and equal to xi?
Okay, so here I'm talking about all the discrete points. Yes or no? We are taking all the discrete point, right? All the discrete. We are talking about discrete. Okay. Let me write x1, x2, x2 up to xn, right? Okay. Where it went? Yeah. So this is the discrete in form 1 to n. Correct? You got likelihood. Okay. From now onward, until you got likelihood 1 upon n raised power n, right?
Yes.
Okay. Tell me, by seeing that value, okay, by seeing that value, this example itself. Now tell me, you have 1, 5, 4, 8, 11, 9 up to 20, these all things, right? And you got, here we have to find the estimate of n. So we'll get how many samples we have? 4, 4, 8, 13, right? Correct? So it will be 1 upon n raised power 13, right? Yes or no?
Yes.
Correct. Now, for which, and just tell me, you have to find the least, least possible of a value for this case, right? The estimate will be which case? The smallest possible value of n such that it should be greater or equal to xi or not. I think, okay, first of all, tell me, if this is the case, right? I should get this log likelihood. I have to equate with the zero. Then it will be maximum.
Yes, sir.
Correct? This is something we are doing in maximum likelihood, right?
Yes, sir.
Now, tell me if when it will be maximum. When it will be close to zero, I mean. It should be maximum value, right? Maximum value, correct?
Yes, sir.
Are you getting my idea what I'm trying to say here? Yes, no? It's a little bit confusing, I agree. Rajiv, are you getting this thing or not?
To some extent, sir, but I have a doubt why we are taking
This greater or equal to thing.
xi, sir. Yes.
Okay, you are not getting. Okay, let me try to explain with the help of continuous uniform. Maybe that from that you will get some sort of idea. Okay, let me take the examples of continuous. Suppose I'm saying x1, x2, xn. This is uniform 0 comma theta, for example. Okay, now what will the PDF? It's a 1 by theta. And what is the case? This is the 0 x theta, right? It will take 0 otherwise. Yes or no? Now
Yes.
tell me, what is the likelihood? It will be 1 upon theta raised power n. Yes or no? And when it will be
Yes, sir.
0 to each xi to theta. Correct? It will take 0 otherwise. So to maximize L, we are going to ignore this 0 part. I mean, so when it will be, now tell me, basically what we have to do. So just focus on this range part, 0, x1, x2, up to I can write xn less than theta. Yes or no?
Yes.
So when theta, it will be you will get the maximum value. I can simply say theta hat ml is the nothing but maximum of all these things. Basically, it is greater or equal to theta 1, theta, greater or equal to x1, x2, xn. Basically, if you see theta cap, theta, okay, in general, theta is what? It is the next, it will be greater or equal to x1, x2, up to xn or not? First of all, tell me, it will be greater or equal to not? Sorry, maximum of x1, x2, up to xn. First of all, tell me, it will be this case or not? Okay, suppose this is the 135. I'm saying this is the greater than, this is the less or equal to theta, or else I'm saying theta is greater or greater than 135. Then can I say theta is greater or equal to maximum of 135?
Yes, sir.
Yes or no?
Yes, sir.
Correct. So what will be the theta hat ml here?
5.
5. Why? Tell me why you have selected 5.
Because it's maximum of all the 3 values.
Maximum of all these 3 values. Now tell me, if this is the 5, just put a scenario. If this is the 5, if you are putting here, okay, since it's actually it's a continuous case, okay. For example, suppose theta you got a 5, so it will be 1 upon 5 raised to, suppose you have 10 sample or some 5 sample, so it will be 1 upon 25, right? Correct. So this is the 0.04 something. Okay, let me try to explain. Suppose you took 1 upon 3 raised power 5, then what it will be? No, it's not 1 upon 25, 1 upon 5 raised power 5. It's the more than that, right? Okay, it's a 0 point, what it will be? 1 upon 5 raised power 5, that means
3125, sir. 1 upon 3125.
1 upon 3125, 3125. That means 0 point 3 times 0 it will be. Okay, let me tell it. 32. For example, 1 upon 3 raised power 5. So it will, you will get, just calculate it, it will be 0.004 something. Okay. Now just focus on the values. 1 upon 1 raised power 5. So I will get 1. Okay. Now you will tell me, you have selected the 5, correct?
Yes, sir.
So you got, which is the least one, no? Least one? In which case we got the least?
When we have selected 5.
Correct? Now are you getting some sort of idea or not?
Yes, sir. Now I'm getting.
Right? I mean, are you sure or
No,
actually?
no, sir. It was a bit confusing question, but I'm getting an idea right now.
Okay. So just what you can do actually, I don't know whether due to my through my explanation did you get or not. Just try to solve them again, right? So you to basically focus on these things, right? These things. Okay? Then you will get this. Fine. Anything else? Anything else, Rajiv or others?
No, sir.
No. Is that all right?
Yes, sir.
Okay. Okay, Rajiv. Rajiv, what you can do? Just try once again. If still you are not getting right, we can discuss more on it. Okay. No problem. Yeah, yeah. You were about to say something.
Sir, I had a doubt in one similar question. Question 9.7, question number 3. It's a
9.7.
Yes, sir. Question number 3.
So it's okay. What is the value then you get? I mean, now till now, the things we have discussed. What you will what you will choose? Okay, let me give you idea. My screen is off, right? Okay. Okay. So tell me, in this case, what we had a lower limit 0, correct? So actually, through the range, you can simply identify. So we have the lower limit 0, right? We had, correct? This is x. This is theta. Then estimate of theta you calculated as greater or equal to maximum of. I mean, it will be equal to basically it's a theta at greater or equal to maximum of x1 up to x2 up to xn, right? Yes or no?
Yes, sir.
Now, in the place of this, we have a, right? It's a x1, x2 up to xn. Now tell me, what will be the estimate of b? Okay, so you can simply say b is okay through this range. I can simply say b is what? B is greater or equal to maximum of x1, x2, xn. If I'm interested to calculate the b, see anyway, if this is the upper limit, right? This should be the maximum value of this exercise. Yes or no?
Yes, sir.
Anyway, now just think like this way. If this is the upper limit, this should be the maximum, correct? This should take the maximum value. Yes or no?
Yes.
If this is the a, then a is what?
It should take the minimum value.
Minimum value, right?
Yes, minimum of x1 to x.
Minimum of x1, x2, xn, right? The same thing if you see in the discrete case now. We have n raised power n, right? This exercise is what? 1 to n, right? Correct? Then what it should take? Maximum or minimum? Okay. So just try to correlate with the continuous case. Now this one is clear. A and B one.
Yes, sir. Yes, sir. Clear.
Yeah.
Yes, sir.
Because it's upper and lower. Okay. Okay. Is there anything else? Anyone?
From my part, no, sir. Thank you.
Okay. Fine. Yeah. Okay. Then if it's there is not anything else, then we can wind up. Okay. Okay.
Thank you.
Yeah. Thank you all. Thank you. Yeah.
Thank you, sir.
Thank you. Hope you got the idea. Okay. We'll. Okay. Yeah. Thanks.
Thank you,
Thanks,
sir.
all. Yeah. Bye.